Well, good morning, ladies and gentlemen. I appreciate the invitation to come and speak to you today about the augmentation systems. Let's see. Because of the basic capabilities that GPS provides today and the commitments that go with that, back in the early 1990s, the FAA came up with a strategy for augmentations. Augmentations improved the performance of GPS. And in the case of the FAA's augmentations, the WAS and the LOS, they improved that service primarily to achieve the objective of guiding an aircraft on a precise vertical path to a runway as low as 200 feet in the case of the wide area augmentation system, or as low as the surface for the local area augmentation. So years ago, we came up with a strategy that involved both those systems. Wide area augmentation system provides an overall coverage for integrity and corrections, improved accuracy service to support en route, terminal, and approach service as low as 200 feet above a runway. And then the local area augmentation system, which due to its increased accuracy and availability would support operations in a terminal area around an airport and down as low as on the surface or in zero visibility. And so I'll talk to you a little more about those two programs. Wide area augmentation system is commissioned in service in 2003. Its objective performance is what we call localizer performance vertical. It's equivalent to the traditional landing systems in use today and is capable of guiding an aircraft down to 200 feet. We have 38 monitor stations in service today. We've just completed a 5-year expansion of the system from 25 stations in 2003 to 38 stations now in 2008 to provide service in Canada, Mexico, and the northern portions of Alaska. So the system is in its final configuration. We have 3 master stations that compute the corrections. We have 4 Earth stations that communicate with 2 geostationary satellites, and the system is controlled from 2 operational control centers. Most of the additional numbers are for redundancy and supportability. 2 geostationary satellites are leased. Pan Am Sat and the Telesat satellites provide dual coverage over that polygon area where our prescribed area for service is required. You can see that the coverage goes much more than what we actually require, and we could consider possibly leveraging that for future expansion if there's a need. So you add all that equipment together and those geostationary satellites, and here's the real-time, a snapshot of the real-time performance that the wide area augmentation system provides. Inside the yellow contour line there is an area where an aircraft receives this signal suitable for flying an approach down to 200 feet above a runway. So what remains, the signal in space is there and it's very reliable, so what you need next in order to take advantage of that and from an aircraft perspective are the approaches and the procedures. A published instrument approach procedure needs to be provided. So as of this year, this actually is a little bit dated, we have a total now of 1,389 of these LPV procedures that are equivalent to instrument landing system approaches. We've been able to do this at 785 runways where ILS is not provided. Also at ILS runways, we've also done it there as well. And to 327 airports where there is no other precision approach capability. So since 1940s, when instrument landing systems were developed, a total of, were being installed by the FAA. To date, we have 1,233 ILSs. So we've exceeded ILSs in 5 years, and our production goals are to increase the number of approaches by 500 per year, so that all instrument runways in the United States, instrument and precision instrument runways, will have a precision approach or a WAS procedure by the year 2018. That's roughly 6,000 runways. So the transition is progressing very rapidly. Now, onto local area augmentation system. Local area remains a developmental program. The objective is to provide category 1, 2, and 3 service at an airport in a terminal area. The benefit is multiple runways can be covered by a single system at roughly the same cost as the legacy systems. It provides 3-dimensional procedures in the terminal area, unlike your instrument landing system, which is runway guidance only. And the accuracy is suitable to support, in combination with improved surveillance systems, closely spaced parallels and what they're calling superdensity operations. So the accuracy of the navigation system itself can't do that, but combined with ADS-B and some of the improved surveillance functions can achieve closely spaced parallels, which is a good benefit. We have a system that is scheduled for design approval and ops approval this year. System design approval is planned for at Memphis in the March timeframe, 2009. From there, the FAA's primary objective for LOS is to achieve a Category 3 capability. Category 1 we have for WAS, but for Category 3, our next step is to make some improvements to the Category 1 system that we've developed such that it can support a Category 3 operation. And what we've learned in the process of developing the Category 1 system is that system, in combination with an auto-land aircraft, taking credit for the capabilities of an auto-land aircraft, which all Category 3 systems are today, can make the job of the ground system a little bit less stringent than what we originally thought years ago when we came up with the requirements. So that's our next step, to validate those requirements in a prototype by 2010, and then by 2012 to have a design-approved system. And this program is part of the next generation air transportation system within the FAA. There are 6, actually more, systems out there at this point. The development activity that the FAA ran into some financial challenges with LOS years ago, and we established a partnership with Air Services Australia. So there's a system installed at Sydney, Australia, and in Frankfurt, Germany, and Bremen, and the other locations that you can see there. So in combination with an agreement with Air Services Australia and some of the other service providers, Eurocontrol and others, we have developed a system that will be approved this year. And as soon as the FAA completes the system design approval, we expect these other locations will also share in that approval and have operational systems shortly thereafter. And most difficult of this system design approval process, as with the WAS, is proving to the numbers of 10 to the minus 7th the safety of the system that will always detect failures and alert the pilots not to use the system when that's applicable. One last augmentation system I'm less familiar with, but the National Differential GPS. The NDGPS actually existed before the FAA's augmentation systems, primarily providing service to maritime surface users on the waterways internal to the U.S. and on the coasts. And you can see NDGPS program has a plan to add additional stations, which is not yet fully funded, is being evaluated, and part of the things that will be looked at in the new administration. So it's similar to a local area concept, broadcasting its correction messages at the kilohertz frequency band. And it complies with the RTCM formats. And that's all I have to say about augmentations. I'll turn it over next to John Merrill.